this video, we're going to be given 3 side lengths and using the law of cosines in its rewritten form to find the angle measurements. And just a very crude drawing, we're going to have angle C, angle B, and angle A, not drawn to scale. And we're going to say side A is equal to 9, side C equals 17, and side B equals 12. And often in a textbook they will draw a triangle like this where the measurements, it's definitely not drawn to scale, so that you really can't guess what the answer might be. We're going to try to find angle A first. So the cosine of angle A is equal to b squared plus c squared minus a squared over 2 times b times c. My understanding here is that angle A is going to be my smallest angle. Cosine of angle A equals 12 squared plus 17 squared minus 9 squared over 2 times 12 times 17. The cosine of angle A equals 433 minus 81. Why I added these together and then subtracted that, I don't know, but 2 times 12 times 17 ends up being 408. This turns into 352 divided by 408. And please understand that this is going to create a decimal number for us to look up on a table, or we can just do it directly in our calculator. When we turn this into a decimal number, we get that the cosine of angle A is equal to 0.8627, and again, we need to use our arc cosine on this to get an actual angle measurement, and we get 30.4 degrees. It's a fairly small angle. If it was an obtuse angle or 90 degrees, I would definitely be worried. But this seems okay. Let's find angle C next. The cosine of angle C, because it's going to be the biggest angle, and I'd like to see what happens with that, is going to be equal to a squared plus b squared minus c squared over 2 times a times b. So for this one we get a squared plus b squared, which is equal to 9 squared plus 12 squared, or 81 plus 144 minus 17 squared, which is 289, all divided by 2 times 9 times 12. Now if we simplify the numerator, we get negative 64. If we simplify the denominator, 2 times 9 times 12, we get 216. When we turn this into a decimal number, we get negative 0.2963. Now, here's the deal. You can't forget that this is negative. So you put in your calculator negative 64 divided by 216. You want to make sure that you get this to be a negative decimal number, because when you do arc cosine on that, that's what's going to give you your obtuse angle. Here we get angle C is equal to 107.2 degrees. And that's our biggest angle. Now we have a little bit of a choice to make. We're going to do this 2 different ways. We can find the cosine of angle B by taking 180 degrees and subtracting angle A and subtracting angle C, because all 3 angles have to add to 180. However, let's just calculate it using this formula: a squared plus c squared minus b squared over 2 times a times c. The cosine of angle B equals 9 squared plus 17 squared minus 12 squared all over 2 times 9 times 17. Again, the 2 is always present there. When we simplify the numerator, we get 226. When we simplify the denominator, we get 306. And when we do cosine -1 on this, that decimal number ends up being 0.7386. So either looking this up on a table or plugging it into our calculator, we get angle B equals 42.4 degrees. Now let's just check our answer. When we look back up at the top of the screen, we've got 180 minus angle A, which is 30.4, minus angle C, which is 107.2. And when we do that subtraction, we do find that angle B is equal to 42.4 degrees. So we do have kind of a quick way of checking our answer if we actually want to go through all the steps. This is how we use the rewritten formula for the law of cosines to find angle measurements if we're given 3 side lengths in a triangle.